The second law that we're going to look at in this gas unit is called Charles' law. And Charles' law is the relationship between volume and temperature. We're going to use the same simulation that we used last time for Boyle's law. So again, I would like you to set up a table where you will record some volumes and temperatures. And again, you're going to have scenarios, say 3 or 4, that you're going to record some values for. We're also going to take note of the pressure in this simulation. So make sure you record that as well as we're looking at our samples. So again, we're going to go into our gas lab, and we need to evacuate the cylinder again, just like we did last time. So just like our last simulation, the cylinder that we're going to fill our gas with is on the left-hand side. We've got our different samples of gases on the right, and that green box in the middle is giving us our readings for pressure, mass, moles, temperature, and volume. So beside your table in your notebook, your pressure that you're going to record once this stops moving will be the same throughout. In your table, you can put in your units for volume and temperature. So our volume is going to be measured in liters, and the temperature is going to be units of kelvins. Okay, so we have evacuated our cylinder that's going to hold our sample. You can record, actually no, at this point don't record your pressure. We're going to fill up our cylinder on the left with a gas. So this time we'll add some nitrogen, and we want to get about 3 grams into our cylinder for our sample. So now if you want to record the pressure, 1.50 atmosphere, that should stay constant throughout this entire simulation. So for scenario 1, your temperature is 273.15 Kelvin, and your volume is 1.70 liters. So for this one, because we're looking at the relationship of volume and temperature, we're going to change our temperature of our cylinder of gas. So pretend that we've got a little heater or cooler that we can change our temperature with. So we've got everything recorded for scenario 1. Now for scenario 2, we want to increase our temperature. So we're going to go up to 323.15 Kelvin. So that's your new temperature reading. And once our volume stabilizes, we're going to record that. So at 323.15 Kelvin, our volume of gas is a little bit bigger. It's now 2.02 liters. And we can look at now what happens if we cool our sample. So for scenario 3, we're going to decrease our temperature. So we've got a little cooler attached to our cylinder. We're going to go down to 223.15 Kelvin. So notice that the piston's going down as we're cooling our gas. It's getting smaller, it's taking up less space. And so for scenario 3, your temperature is 223.15 Kelvin, and your volume is 1.39 liters. So again, if you pause the video, see if you can figure out a mathematical relationship of volume and temperature, and then we'll get back to the lesson and use that formula that hopefully you come up with. So by now you've had the opportunity to come up with the mathematical relationship of volume and temperature. And there are definitely a few different formulas or calculations that you can do. Typically, the way Charles' law is written is V1 over T1 is equal to V2 over T2. And there's certainly other ways that you could write that relationship. This is just the common way that you'll see it. And once we combine this together with Boyle's law in the next lesson, it's going to make sense why we have the volume on top. Remember that just like for Boyle's law, there's things that need to be held constant. So amount of gas or moles and pressure must remain constant if you're using Charles' law. And we have to have the same units when we're doing these calculations because these are ratios. So volumes have to be in the same units, either both milliliters or both liters. And temperatures always have to be in units of kelvins. So let's do a couple of example questions with this relationship. The first one we're looking at is 3 liters of hydrogen gas at STP conditions is heated to 35 degrees Celsius. What is the new volume of the gas? So we have our first volume, V1, of 3 liters, and we know STP conditions is what we're starting at. So what that's actually giving us is the first temperature, or T1. If you remember what STP stands for, standard temperature and pressure, the temperature that goes with that is 0 degrees Celsius, and that's equal to 273.15 Kelvin. So there's T1. When that's heated to 35, that becomes temperature 2. Our temperatures we know have to be in Kelvin, so we're going to have to convert that. So let's do that on the side. T2 is 35 plus 273.15, and that will give us our temperature in kelvins, so 308.15 Kelvin. Question is asking for the new volume, so what we're looking for in the question is V2. This relationship or mathematical formula is a little bit more difficult to rearrange. Make sure that you know how to solve for each of those 4 variables. If we rearrange to solve for V2, we want V1 times T2 over top of T1. Now that we've converted our temperature, we can substitute in all of our values. So 3.00 liters for V1. Temperature 2, we changed to 308.15 Kelvin. And temperature 1 was 273.15 Kelvin. That came from our STP conditions. So answer with 2 significant digits comes out to 3.4 liters for our new volume. Let's do one more example. A child blows up a balloon with 1.24 liters of air in a room at 20.4 degrees Celsius. So 1.24 liters is our starting volume, V1, and 20.4 degrees Celsius is our starting temperature, T1. Because it's in degrees Celsius, we know we're going to have to change that. If the balloon is put into a freezer and shrinks to 1.14 liters, what is the temperature of the freezer in degrees Celsius? Our 1.14 liters is our second volume, V2. We're looking for a temperature, so that means we're looking for T2. Even though we're looking for degrees Celsius in the answer, we still have to do all of the calculations using absolute temperatures or kelvins. So if we start with our rearranged formula to solve for T2, that's going to look like T1 times V2 over top of V1. Our first temperature of 20.4 degrees Celsius, we need to change into Kelvin. So we're going to add 273.15. Our volume 2 for the formula is 1.14 liters. And volume 1 that goes on the bottom is 1.24 liters. So make sure you do your calculation of temperature. First off, get that value. It comes out to 293.55. Then multiply by the 1.14 and divide by 1.24. So that calculation gives 269.88 Kelvin with a few other decimals. Make sure that you leave all of those decimals in your calculator. For the second part, to change it into degrees Celsius, now we need to subtract 273.15. So the 269.88 that you still have in your calculator minus 273.15 will give us our answer in degrees Celsius. Negative 3.27, 3 significant digits is what we want for the answer for this question. Last thing we need to consider for Charles' law is the graphical relationship of volume and temperature. For Charles' law, volume and temperature are directly related. So this means that as one increases or goes up, the other variable is going to do exactly the same thing. It's also going to increase. On a graph of volume and temperature, that means we're going to have a straight line that connects our two variables that goes up to the right.